Hello, and welcome back to the final speedrun of today. Well, actually not really, because we still have to do the chapter review, but the final speedrun of chapter 3.6. And yeah, let's jump right in. So, we've already learned how to solve a system of two linear equations, and so we need to progress, and we need to learn how to solve a system of three linear equations. So say, with three different variables. So say x plus y plus z is equal to 0, x plus minus y plus z is equal to 1, and x minus y minus z is equal to 2. This is an example of a system of three linear equations. And just like the system of two linear equations, there are three possible outcomes. The first outcome is that there is one triplet like x, y, z, and only one triplet that satisfies this equation, and so all three of these linear lines would intersect at some point. The second outcome is that there are no there are no triplets that satisfy all equations, so this just means that all three lines don't intersect at a point. They can intersect at three different points, but all three lines must not intersect at one point. And so, finally, there can be infinitely many triplets, and that's again if all three lines are like the same line. So yeah, that's pretty much it. And the other thing that you may want to consider is that we can actually get the equation of a polynomial given some points by factoring it into a system of linear equations. But I guess we'll talk a bit more about that when we get to questions on it, because it's hard to explain it without having a question in front of us. So let's jump right into the question. So the first question is we need to find the value of the parameter m such that the system has no unique solutions. And the system is 2x plus y minus z is equal to 4. X minus y plus mz is equal to 2, and 3x plus 2y minus z is equal to 1. And so we want to work on eliminating x and y from the equation so we can find an equation for z in this scenario. So how would we do that? Well, what I would do is I would start off by subtracting this. We would double this equation and subtract this equation from it. What do I mean by that? Well, it's like this. So we have this is equal to 4x plus 2y minus 2z, and this is equal to 8. And if we subtract 3x plus 2y minus z from this, we get x minus z is equal to 7. So that's one equation we can use. And then I also want to use these top two equations and just subtract them from each other to eliminate the y value. Actually add them together. So there we get 3x plus m minus 1z. Oh, can't draw z. M minus 1z is equal to 6. So now we have a system of two linear equations. X minus z is equal to 7, and 3x plus m minus 1z is equal to 6. So from here we can say that x is equal to 7 plus z and substitute this into there. So we have 3 times 7 plus z, which is 21 plus 3z, plus m minus 1z is equal to 6. So we have this over here, where m plus 2z is equal to 6 minus 21, which is equal to negative 15. So z is equal to negative 15 over m plus 2. And remember, we want to find the value of m for which this has no solution. This will have no solution if it's impossible to divide the denominator. So in this case, if m is equal to negative 2, there will be no solution to the system of linear equations. So m equals negative 2 will be our answer. Okay, Go to the next one. And the next question is asking us to find the values of the real parameter k. So the system has infinitely many solutions, and the system is 2x plus 3y minus z is equal to 1, kx plus 9y minus 3z is equal to 3, and 3x plus 7y plus 5z is equal to 2. Okay, we need to notice that the top and bottom equations are of the four. Well, the bottom equation, all of the coefficients is 3 times the top equation. So if we make k 2 times 3, which is 6, then we should have infinitely many solutions for these two, and therefore we should have infinitely many solutions for the entire system. So k equals 6 should be the answer. The book says k is not equal to 6, and I think they're wrong. I think they put the wrong sign. Okay. Finally, we need to find the equation of a quadratic function that passes through the points. And this is what I mean by constructing a system of linear equations to find the polynomial. So if we're given the points 3, 1, -2, -5, and 1, 4, we can construct a system of 3 linear equations that we can use to solve this and find the equation of the polynomial. Because we know f of x, so 1 is equal to a times -3 squared plus b times -3 plus c, where a, b, and c are all real numbers. So this is equal to 9a minus 3b plus c. We know that -5 is equal to -a times -2 squared plus b times -2 plus c. So this is equal to 4a minus 2b plus c. And finally, we know that 4 is equal to a times 1 plus b times 1 plus c. So now we have 3 linear equations that we can use to solve this problem. So we need to find what a, b, and c are. So I think the simplest step would be eliminating c from both equations. If we subtract this third one from the first and second, we'll get that. So 9a minus 3b plus c minus a plus b plus c. Well, I mean, this is really 1 and 4. So we would get -3 is equal to 8a minus 4b. Okay. Well, we now need to look at the we now need to look at the second one. So if we have here if we subtract 4a minus 2b plus c, and we subtract a plus b plus c, of course this being equal to -5 and this being equal to 4, well, we'll get -9 is equal to 3a minus 3b. And so now we can plug this in. So, well, we know -3 is also equal to a minus b. So if we substitute this is equal to that, we have 8a minus 4b is equal to a minus b. Or actually, I think we can just do it the even simpler way at this point. We can say that a is equal to b minus 3. And so we substitute this here. So -3 is equal to 8 times b minus 3 minus 4b. And so we have 4b is equal to -3 plus 24, and 4b is equal to 21. So b should be equal to 21 over 4. Okay, and then so we need to solve for a is b minus 3. So a will be 21 minus 12 over 4, which is 9 over 4. And what's c? Well, c is equal to Well, 4 is equal to a plus b plus c, so we can use that. So we know c is equal to 4 minus 21 minus, plus 9 over 4. So that's equal to 4 minus 30 over 4. So that's equal to 16 minus 30 over 4. Otherwise, that would be negative 14 over 4, or negative 7/2. So yeah, those should be the 3 answers. And so therefore, our polynomial looks something like f of x is equal to is equal to 9 over 2 x squared plus 21, 9 over 4 x squared. Where did I get the 2 from? 9 over 4 x squared plus 21 over 4x minus 7 over 2. So yeah, that was it for this speedrun. I hope you're now confident in solving systems of linear equations with more than 2 variables, and I hope to see you in the next speedrun.